Good viewers, this is 300 Plus Academy, where all we do is exams tutoring, ensuring that you ace your next exams. Of course, this is the last topic as far as percentages, ratio, rate, proportion, and mixture is concerned. It's a thing in mathematics, it's a series. So we'll be looking at mixtures or blends, not the mixtures we have in chemistry, but this time we are looking at how to create mixtures from given information mathematically. So when we say mixtures, mixture involve combining things such as solutions or objects together to create a desired blend. And there are certain steps that we take in combining solutions or objects together to create the blend that we want, the composition that we want. The steps to follow is this. We use a variable to represent the unknown quantity in the problem. Secondly, we create an equation involving that variable we've created in one. And then thirdly, we solve the equation we've created for that variable. We solve that equation involving that variable. And lastly, we answer the question posed in the problem. When we talk about mixture, it's more understandable when we get, hands-on solving mathematical problems. Someone here has 80 liters of a 30% or needs 80 liters of a 30% solution. But here, what he has is 20% solution and 60% solution. So that is the problem. What we have is different from what we need. How do we solve it? These are the 4 steps we are going to follow. We will use a variable to represent the unknown quantity in the problem. Then we are going to create an equation that contains that variable. We will solve for that variable and then answer the question posed in the problem. So these are the 4 steps we follow when we have questions that has to do with mixtures or blends in situation where what we have is not what we need. So we need to create a blend from what we have. Looking at the question you have on your screen, this person needs 80 liters. 80 liters of 30% acid solution. Currently has 20% solution. This person has 20% acid solution and 60% acid solution. So the question states, how many liters of each does he need to make this? So the thing is very simple. We want to create this, but this is what we have. This is what we have. And this is what we need. This is what we need to create. So we need to mix this and this. Hence, we talk mixtures. Hence, we talk about blends. So this is very simple. So using those 4 steps I highlighted earlier, since you need 80 liters solution, I could say let's have X liters of this. If this is X liters, then this, since we are creating 80 liter solution, then let this be 80 minus X. In other words, if you create X liters of the 20% solution, and if you create 80, if you then add 80 minus X liters of the 60% acid solution, you want to create 80%. 80 liters of the 30% acid solution. Look at it very well. Think of a variable. This is my variable here. So this is what I have. I need to mix this and this to get this. So what I'm doing is x liters of the 20% solution plus 80 minus s liters of the 60% solution should give us 80 liters of the 30% solution. So this is 20x plus 60 times 80, that is 4,800, minus 60x equals to 2,400. 80% or 80 liters of the 30% solution. So that what I have here is 20x minus 60x equals to 2,400 minus 4,800 minus 40x equals to minus 2,400. So x equals to minus 2,400 divided by minus 40, so that my x equals to this off. My x here equals to 60 liters. The implication of that is very simple already. It simply means that for the 20%, it simply means that for the 20% acid solution, I'll need 60 liters because that is equal to x. For the 60% acid solution, I'll need to take 80 minus x, and that is 80 minus 60, that is 20 liters. And that just answers the question. 60 liters and 20 liters. You want to look at the question again. The question says, how many liters of each does it need to make the needed 80 liters of acid solution? So you need 60 liters of the 20% solution and you need 20 liters of the 60% solution. So look at the process again. This is what you need. This is what you have. So you need to, create a variable by yourself, and you need to then mix things up. So I am saying let us take s liters of the 20% acid solution, and since the whole liters we want to create is 80, if this is x, then this will be 80 minus x. That way I'm already trying to create an equation using that x variable. So what I have here is x liters of the 20% solution and then 80 minus x liters of the 60% solution to give me 80 liters of the 30% solution, and then I solved for the variable that is x. Coincidentally, this is x. So I need 60 liters of the 20% acid solution, and then I need 80 minus 60, that is 20 liters of the 60% acid solution. So that is the process we follow when we are dealing with problems involving mixtures. So that ends that question. Moving on to another question, as you can see on your screen. Jonathan needs 70 liters of a 50% alcohol solution. Jonathan needs. This is what Jonathan needs. This is what he wants to create. Jonathan, according to the question displaying on your screen, needs 70 liters of a 50%, 70 liters of 50% alcohol here. Needs 70 liters of 50% alcohol solution. What he has, this guy has 30% solution and 80% solution available. He has 30% of this and 80% available. So we've been asked, how many liters of this does it need to create this? So I'll say let this be x liters that it needs, and then this, since we are creating 70 liters, and then this will be 70 minus x liters. That is what it needs to create. So I'll say you need x liters of the 30% solution plus 70 minus x liters, 70 minus x liters of the 80% solution to create 70 liters of the 50% solution. So that this means 30x plus 70 times 80, that is 5,600, minus 70x equals to 70 times 50, 3,500. So this is the equation I need to solve. 30x minus 70x minus 40x equals to 3,500. This moves to the other side, minus 5,600. And here, this is going to give you 2,100 minus 2,100 minus 40x. So x equals to minus 2,100 divided by minus 40. Minus cancels minus. 52x equals to 52.5 liters. What we're going to be looking at is, for the 30% solution, I need x. X is 52.5 liters. Now, for the 80% solution, I need 70 minus x. So that's 70 minus 52.5. That is 17.5 liters. So for the 80% solution, I need 17.5 liters. When I mix this and this, that is when I'll be able to create 70 liters of 50% alcohol solution. So this is just what mixture is all about. Moving on to the next question. As you can see on your screen, it says, how much water must be evaporated from 80 pounds of a 12% solution of salt in order to obtain a 20% solution? So what this means is that we have an 80 pounds of a 12% solution. Okay, let this be 80 pounds of 12%, 80 pounds of 12% solution. Okay, how much water must be evaporated? So which means we want to drive out water from this. Let the water drain out. Let this water be x pounds. So that when we drive out this water, when this amount of water is evaporated, we are going to be left with a 20% solution. Of course, if that be the case, this was 80 pounds before. If we've driven out x, it now means the solution will be 80 minus x pounds. So that we've been able to, get a variable for this. So for us to create an equation now, what we had before was 80 times 12% solution, which is equal now to what we have is 80 minus x times 20% solution. So this means 80 times 12, this is 960, equals to 20 times 80, that is 1,600 minus 20x. If minus 20x comes here, we have minus 20, we have plus 20x, 1,600. If this moves here, minus 960. So that what we have is 20x equals to 640. So x equals to 640 divided by 20. 640 divided by 20, so that x equals to 32 pounds. That is the amount of water that must be evaporated for us to have a 20% solution. And that ends that question. Moving on to the next question, as you can see displaying on your screen, you have a 20% solution of fertilizer, which is to be mixed with 70% solution of fertilizer. So we have 20% solution, which is to be mixed with 70% solution. Okay, that's the first thing you see in that question there. In order to get 50 gallons, of a 60% solution, okay, this is in order to get 50 gallons of a 60% solution. So the thing is this and this give 50 gallons. So I'd rather say, let this be X gallons and let this be 50 minus X gallons. That way, I'm using X as my variable, and from this I can now create my equation. So in this situation, you're going to have 20% of X gallons. That's 20 times X plus 70% of 50 minus X gallons. So you're looking at 50 minus X of the 70% solution of 70 to give us 50 gallons of the 60% solution. So this is going to be 20x. This is going to be 3,500 minus 70x equals to 3,000. Okay, so what this means is 20 minus 70x, that's minus 50x, equals to 3,000 minus 3,500. 3,500. So what that means is minus 50x equals to 3,000, that's minus 500, minus take out minus x equals to 500 divided by 50, x equals to 10 gallons. The implication of this is that for the 20%, solution, it is x gallons we're talking about. So x here equals to 10 gallons. For the 70% solution, what we will need to add to the 10 gallons is going to be 50 minus x. So that's 50 minus 10, and that is 40 gallons of the 70% solution. So this way, when we mix things, we're going to get 50 gallons of the 60% solution. X was our variable. We created an equation with it. We solved for the equation. Then we answered the question. As you can see on your screen, you invested $3,000 between two accounts, paying 5% and 9% annual interest. So what we want to do here is we want to invest $3,000 between two accounts. Let this be account A, let this be account B. This one was producing interest at 5%. This is at 9%. That's what the question states. 5%, 9% annual interest respectively. If the total interest earned, okay, the total interest earned was if the total interest earned was $230, how much was invested at each rate? Okay, now let's look at it. This is investment at 5%, this is at 9%. So I'd rather say let the investment here be X. Then the investment here will be 3,000 minus X. The implication of that is, what is 5% of X? And here, what is 9% of 3,000 minus X? So this is the interest. This is how this was invested here. This was invested here. So this is how we calculate the interest. This is the interest. So this plus this should give us the total combined interest, as you can see from the question, which is $230. So this will mean 0.05x. 5 over 100 is 0.05 plus 0.09 into bracket 3,000 minus x equals to 230. So 0.09 times 3,000 equals 270 minus 0.09x, and then I have 0.05x here plus equals to 230. So the implication of that, this has to move so that I'm left with 0.05x minus 0.09x equals to 230 minus 270. I'm going to get minus 40 here. This is going to be minus 0.04x, so that x equals to minus 40 divided by minus 0.04. This off. The answer here is going to be 1000. So the implication of this is that since my x is 1000, for the account where we are investing at 5% simple interest, our x here was 1000. So that is, we are investing x. So this is $1,000 at 3000 at the account where we are investing at 9%. We are looking here at 3000 minus x. 3000 minus the x here means 3000 minus 1000. That is $2,000. So basically, we are investing $1,000 here and we are investing $2,000 here. So this is another example of mixture. Get a variable, form an equation with the variable, solve for the variable, use that answer you get to solve the problem in the question. It's a simple 4-step process. And last but not the least, let's quickly look at a UTME question to buttress what we've been saying about mixtures and blends. We have 1991 question 7. 1991 question 7. Okay, what do we have there? It says, if 3 gallons of spirit containing 20% water, it says, if 3 gallons of spirit, 3 gallons containing 20% water are added to 5 gallons of another spirit. 5 gallons of another spirit containing 15% water. What percentage of the mixture is water? Someone wants what percentage of this mixture is going to be water? Of course, 3 gallons and 5 gallons will give us 8 gallons. 8 gallons of, let x be the percentage. Look at it very well. 3 gallons of 20%, 3 gallons of spirit containing 20% of water plus 5 gallons of spirit containing 15% water were mixed together. Obviously, we're going to have a certain percentage of water, but 3 gallons plus 5 gallons gives us 8 gallons in total. So this is our variable here. This is the equation we have to solve. 3 times 20 is 60. 5 times 15 is 75 equals to 8x. So this is 135 equals to 8x. 135 over 8 equals to x. Therefore, x equals to, how many 8 can we get in here? That is 16. Remainder 7 over 8%. That is the percentage of water we are going to have in our mixture. You see, when you mix 20% water, 15%, it just goes a bit above 15 and a bit below 20. So this is it. And if you look at the option in that question, that is option B. And with that, we've come to the end of this series talking about percentages, ratio, rate, proportion, and now mixtures. Do not forget, this is the place to be to ace your next exam. Hit the subscribe button, turn on notification, and of course, share with your friend. They'll be glad you did. From myself and the entire team here, is bye for now.